Physiotherapy, or known as physical therapy, is a healthcare profession focused on helping individuals recover, maintain, or improve their physical function and mobility. Physiotherapy uses a variety of techniques such as exercises, manual therapy, or other modalities to treat conditions related to injuries, disability, or illnesses. Their goal is to alleviate pain, restore movement, and enhance overall quality of life for their patients. In our innovation project, however, we are predominantly focused on neurological disorder, specifically loss of muscle memory.
While physiotherapy is a valuable and effective healthcare profession, it's not without its limitations and potential flaws. Can it or can it not? Physiotherapy is a recovery method that has no parameter, which means, in the long run, patients might lose hope with the effectiveness of this treatment. And they will, because physiotherapy is extremely time-consuming and without a significant assurance that the treatment can help the patient to fully recover. Equipped with motorized way to find an equilibrium during the therapy session, each device is customizable to the level of intensity as set by the user or trained physiotherapist, specifically designed to assist users recovering from physical strain such as stroke or muscle issues, or improving and maintaining a certain level of physique prowess.
The first part of our programming sheet is the micrometer accuracy. The micrometer accuracy is the mainframe settings that became the standardized setting for all three of our products. So, to be honest, this is the proprietary aspect of our programming because I truly believe that there is no other team out there that is capable of harnessing this type of program because it's a multi-layer program and it is defined and attuned according to the settings needed for each product. So you can see that we are outsourcing it from the Thinker, so we can access it and harness it in Android settings applications such as Samsung and whatnot. Alright, next we move to the main sheet of our program, which covers the wrist and hand exercise as well as the finger dexterity. So both of these settings involve motor use, and the motor has spacious convenience for the product to be accessible for the customers using QR code or applications. And the spacious convenience allow the customer to adjust the settings based on their need. So it will be able to help the customer adjust their rehab treatment from level 1 to level 5 by using the motor settings. Alright, now moving on to the second part of our main sheet program, which is the rehab exercise. The rehab exercises are divided into two programs, which is the basic writing as well as the basic drawing. So once the main window and the UI components is set up using Thinker, it creates a dynamic equilibrium in our programs to ensure that the main settings and the mainframes remain intact. So the settings are adjustable using QR code or the application provided by us for our customers, and then the settings are adjusted to the level of treatment that the customers are currently undergoing. So because of that, we left spacious convenience for people to adjust their settings as well as commands that is reflected to ensure the process remains intact. So the latest addition in our program sheets is Swift to expand our market for iOS and Apple products. With children as our target audience, we built a treasure hunt team game using Swift coding programs outsourced into a spherical shaped gamepad with UI kit as its frame component. So why we prefer using UI kit is because we can ensure you, after various updates, the frame component will still remain intact. Okay, using gestures to control the gamepad, we implement rehab elements that utilizes finger muscles. The patients are required to move the avatars forward, backward, left and right, as well as a double tap option to collect treasures and change the avatars from a selection of 3 or more. So this list can be expanded with time. So the game is also designed dynamically, so wrist rotation is needed to control the VCAM. With ready-made commands that is already installed in the game, the patient should have no difficulty to adjust or even play the game with increasing difficulty.
Adhering to the robot-assisted blade training, our systems are used to help patients relearn motion patterns by carrying out tasks involving mobility. In the case of finger and wrist motions, tasks vary from basics such as simple writing to advanced ones such as cursive and weighted movements. Any form of progress, stagnance, and regression will be collected as data so that patients themselves to track improvement and make necessary adjustments to the treatment plans. The minuscule margin of accuracy will contribute to the effectiveness of this method according to every patient's need. When a parameter is placed, nothing is impossible.
Good health and well-being. Our innovation aims to provide effective treatments in physiotherapy and allow it to be a commodity available for all patients.
Decent work and economic growth. Our innovation not only opens up a new sector of research, fostering work for researchers or any STEM practitioners in R&D, but we also improve biomedical engineers' quality of work. Working closely with hospitals will also allow economic growth as our innovation is made available to own for patients through healthcare distribution channels. Partnerships for the goals. Our innovation will create branches in robotics and Legos to intertwine. Prolific companies will be of interest to develop collaborative relationships with our designs. Examples such as AI technology companies and privately owned health institutions.
With this innovation made accessible, home exercise programs can now be elevated to an even better standard. Portable, easy to use, and equipped with the necessary modernization to continue forward. In conclusion, issues regarding effectiveness, time constraint, financial problems, availability of both equipment and physiotherapists can be tackled simultaneously.